Hi, this is Mrs McTaggart. In today's video we are looking at angles in a circle. This would be lesson 1, looking at triangles within a semicircle. Now this actual part of the topic is technically only National 4, but it is incorporated in all the more difficult National 5 questions. So what happens is whenever you have a circle and you draw your diameter as shown going right through the centre, if you draw a straight line going from any end of that diameter to any random place on the outside of the curve, now I don't have a ruler or a straight line application to be able to do this, but if you draw a straight line going from the outside to one side and the outside up to that point, then this is a 90-degree angle. And normally if I was in class I would bring in a protractor to show you it, but it does look like 90 degrees, albeit my lines aren't perfectly straight. You know, it could be anywhere, it could be underneath as well, so I'm going to do another one. So even here, this would be a right angle meeting up at the centre. So anywhere at all, as long as the triangle is bound from the two sides of diameter to anywhere out in the curve, the bit out in the curve will always be 90, and you have to spot that in all the examples that you're going to be seeing from here on out, okay? So a little reminder that angles in a triangle always add to 180, and then if you're copying this down, this is what I get you to write in the note, that this one, triangle ABC, is right angled at B. We reminded that the middle letter is the angle that we're always talking about in maths. So this is a right angle at B, and this is true for any triangle inside a semicircle, as long as you have your diameter there. So what I sometimes see is that maybe something like this in class, and pupils will go, oh, that's 90 on the outside. It's not, because this line here is false. That line has to go to the other end of the diameter, okay? It has to be a triangle fully within a semicircle using the diameter as one of its sides. Let's look at examples. So example 1 is asking us to fill in all the missing angles here. So if you look for your right angle, first of all, the right angle is here at B. It's at the bit on the curve, okay? So a lot of people sometimes want to think that's 90, but it's not. It's a bit out at the curve, and it actually does look like it's 90 as well, okay? So there is my 90 degrees. That is enough for me to then get this other angle here in this triangle by simply adding the 90 to the 25. So if you do 90 plus 25, you have 115. And the angle that we are after is then 180, take away 115, which is 65. Now you can do sums or you can do this mentally. So that angle in there is 65. Now we have another little triangle here, and this bit actually gets talked about more in the later videos. And whenever you have a line coming from the centre to the outside of a circle, you have a radius. And here is another one from the centre to the outside is another radius. So we've actually got a little isosceles triangle going on there. Now these two angles here are on a straight line. So the angle at the top of this triangle would be 60, because 180 is the angle of a straight line. 180 take 120 makes that 160. And in actual fact, this isn't an isosceles triangle, it's actually an equilateral triangle, because if you think of an isosceles triangle, and if I've told you it's 60 at the top and these two sides match, you would do 180 take away 60 to leave you 120. So these two angles are like mirror images of each other, they match, and there would be half of 120, which is actually then going to be 60. So these angles are all 60, and in actual fact it's an equilateral triangle if all three angles and sides match. Okay, let's have another one. This one here, we first of all look for the right angle. The right angle is up here on the outside of the semicircle. We know that these two angles here are on a straight line, so they make 180. So if you do 180, take away 127, you'll be left with 53. So this angle here is 53. And then that's, you've got enough angles, you can now get this final one within the triangle. So you then do 90 plus your 53, which is 143. 143 away from 180 leaves you with 37. So this angle over here is 37. It's also worth noticing that this angle and this angle here both make 90, because two 90s make 180, and if there's a 90 within the triangle, then it's given that the two acute angles also make 90 as well. Okay, so this is a point if you wanted some more practice. This is the questions I would put on the board in the classroom, and rather than sketch them, I have labelled all the angles you should find. So you could pause and try these if you want, and then when you unpause, the answers will be there for you to check, and hopefully you got on okay. Thanks very much for watching. I know it's been a very short video, but I hope it's helped. Thanks.